Hello, welcome to this clip going through a leveled response question on enthalpy, but from an A2 perspective. If we have a look through the question, it shows a procedure that a student has followed, and then some results and a calculation that the student did following those results. Right down at the bottom, it gives you three instructions if you look at the question. You've got to suggest improvements, list the mistakes in the student's calculation and find the actual delta newt H from their data, as well as calculating the percentage error of the thermometer. So the way the instructions are laid out means that there's three strands to your answer. So you've got to focus on the procedure first of all, calculation errors and corrected calculations. Notice I just put it under a little subheading called plan. Even if it takes 30 seconds to have a think about, it's worth actually putting your pen down and having a think about it first, because although it's 6 marks, you'll usually have about 8 or 9 minutes to complete it in an exam. If you look at the mark to time ratio in a normal exam from the 2015 specification onwards, you're looking at about 1.3 minutes per mark. So this allows you to think and plan what you're going to put down. So you've got three simple things to talk about, so now we can lay out our answer. So looking at the first mistake, obviously they haven't talked at all about how they insulated it or prevented heat loss. So mentioning that is important. And looking at where they've recorded their temperature change, it's only recorded as 16, should be 16.0, because all the other recordings are 1 decimal place. So the first thing to do is to actually check the most basic calculations. Now the calculation is fine for the number of moles of magnesium hydroxide. However, what you've got to think about is how many moles of magnesium hydroxide would react with how many moles of sulfuric acid. So if we check the mole ratio from the equation, and we can see that it's 1:1 between magnesium hydroxide and sulfuric acid. Now we need to check that that's actually the case using the amounts that were given. So we've already calculated that magnesium hydroxide is 0.01 moles. Now if we calculate it, we can see that the number of moles of sulfuric acid doesn't actually match the number of moles of magnesium hydroxide. So that means that the sulfuric acid is a limiting reagent and therefore will control how far the reaction goes. So that means that the magnesium hydroxide is the wrong reagent to use in their calculation. You must use the limiting reagent to decide how much energy is released. The second mistake is the Q equals mc delta T calculation. Because the density of the final solution is 1.5 grams per centimetre cubed, and we had 100 centimetres cubed of it, we needed 150 grams, not 100 grams, as I've indicated with the arrow. Now looking at the value for delta newt H, it should be negative because the reaction is exothermic. I'm just going to move my corrected calculations section down a little bit. So how do we know this is exothermic? If we look at the temperature change data, you can see that there's a rise in temperature, so therefore delta newt H, or delta H of any kind, should be negative in this particular case. Now they also forgot to convert joules to kilojoules because, as you know, the value that comes out of a Q equals mc delta T calculation is in joules, but a delta H value should be in kilojoules. So what they've done is they've written it as kilojoules, but haven't done the correct conversion. In case you're wondering where the H2O went in the equation, it's because I wanted to draw attention to it. So change it to black and just draw attention to the fact there's 2 moles of water. So their final answer needs to be divided by 2 because delta newt H refers to 1 mole of water, not 2 moles of water. So let's now go back to the beginning and do the corrected calculation. So we need to start off by calculating the amount of H2SO4 that actually reacted. So that gives us 0.005 moles. And if we do Q equals mc delta T, we get 10,032 joules. So to work out delta newt H, you need Q in kilojoules divided by the number of moles of water that was made. Now because there was 0.005 moles of H2SO4, that must mean that there's 0.01 moles of water made, because it's a 1:2 ratio from the equation in the top left. So instead of dividing 10,032, or should I say 10.032 kilojoules, by 0.005, I divide it by 0.01, because that represents the number of moles of water that's been made. So if you put that into a calculator and account for the fact that it is an exothermic reaction, that gives you minus 1003.2 kilojoules per mole to the minus 1. So the final thing to do is to calculate the percentage error of the thermometer. So because it's a reading by difference, that means you've got to double the error of each reading, because the measurement, which is 16, came from having read two different readings. So therefore 0.5, which is your maximum error for one reading, has to be doubled, and divide that by your overall measurement, which is 16, then times it by 100, which gives us 6.25%. Okay, so I hope that's been a useful roundup of how to do this type of question. It was slightly involved because there's lots of different things to consider, but if you go at it nice and methodically and have a little think about it first before you start writing, you should be able to catch most of the things that you're meant to do. At the end of the day, it's just an extension of your first year chemistry. It's essentially a Q equals mc delta T calculation, but there's been some traps thrown in there to see if you can spot where mistakes are made and where the calculation needs to be put right. Okay, so thanks for listening, and until next time, see you soon.